Hello everyone. Welcome to another educational video of Odtutor.com. In this video, you will learn how to connect electrical loads in series and parallel. So to demonstrate that, we will use a very simple simulator over here. It is an electrical simulator, and in this simulator, we will create series and parallel connections for you so that you can understand. We will try to connect 2 or 3 light bulbs in series and parallel connection, and then we will show you current, voltage and different measures so that you can understand what happens in which particular case. So first we will take series. So first let's take example of series connection. In order to understand this, let's take a voltage source. So this is a voltage source. As you can see, this simply looks like any battery or a cell that you put in your uh, wall clock or something, right? In toys you must have used this. It comes in A, double A and triple A specifications. So let's measure what is the voltage of this voltage source. So red is positive, black is negative. Let's connect this and you will see that let's let's connect to its ends. So we have a voltage of 9 volts. Okay, now our battery has 9 volts. In series connection we will connect 2 or 3 bulbs in series. So first we will add one wire with our battery. So with our battery we have added one wire, and then with this wire we will attach this load. Okay, this is our simple load that we are attaching here. If you will click on it, its resistance is 10 ohms. Every electrical load has some resistance, so its resistance is 10 ohms. Okay, now in order to connect it with series, so uh, when you have a bulb or when you have any electrical load, you will see that it has two terminals. Okay, since we are creating a DC circuit, so it will have a positive terminal and a negative terminal. So we will connect our one end of our electrical load with the positive wire, and then we will connect another wire with it. Okay, so we have this wire. If you will click on this wire, you can either delete it, and then we'll connect another load. Okay, so this way we have connected two bulbs with one electrical voltage source. Okay, and now what we will do, we will take another wire and we will complete the circuit, but we will put a switch in between. Okay, just for understanding. So this is how we have connected two voltage sources in series. Okay, and when you will turn the switch on, you will see that electrons will start flowing from the positive end to the negative end of the battery, and hence the circuit is complete and you can see the bulbs. We will click on values to see their respective electrical parameters. Bulb has 10 ohm, another bulb has 10 ohm, and let's try to measure the current. So we will place this current meter over our circuit, which is 0.45. So this, in this case, these two resistance will add up and your total resistance will be 20 ohms, and hence since your battery voltage is 9, and as we discussed in the previous video also, if you remember, otherwise as per Ohm's law, in a circuit V is equal to IR. In a closed circuit, V is equal to IR. So in series you have to remember the total resistance of individual elements is added. So let's say resistance of one element is R1 and other element is R2, then total resistance will be R1 plus R2. In our case, both have 10 ohm resistance, so it will be 20 ohms. Total resistance will be 20 ohms, and our voltage is 9 volts. So 9 is equal to 20 times I. Okay. So in order to prove this, we can also assume our resistance is R. Let's say the total resistance is R. And we can see through our experiment that the total current is 0.45. Okay. So this means 9 is equal to R times 0.45, and hence R is equal to 9 divided by 0.45, because this will simply come over here. So 9 divided by 0.45 will be R, and obviously you can take out the decimal, it will be 900. So it will simply come as 900 divided by 45, and which is nothing but 20. So when the total resistance is 20 and we have two resistances, hence one particular element will have a resistance of 10 ohm, we simply proves that in a series circuit resistance are added. Now this was a simple demonstration of series circuit, and now we will discuss parallel circuit. So on our website odtutor.com, we have created a simple article about this as well. We will provide the link in the description. So you can see in a series circuit, resistances add up, which is R1 plus R2 plus R3, which we just discussed. And in a parallel circuit, the formula for calculating total resistance is actually this. So it is 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So let's say if the resistances are 5 ohm, the resistance 2 is 3 ohm, resistance 3 is 2 ohm. So it will be 1 by 5, 3, 2. If we take the LCM, it will be 30. Then you can calculate the complete thing. We actually have this calculator, let's say 5, 3, 2, and output resistance will be 0.97. So using that same formula, okay, so as you can see here on this website allaboutcircuits.com, we can see we have a voltage source, and then we have to connect the resistances like this. Now let's do this on our simulator and see how it can be done. So let's clear everything. First of all, we have to take our battery, which is our voltage source. You can take AC voltage source here as well if you want to try this simulator. Even there are many good simulators out there, you can try. And then you can connect a wire here, and you can connect another wire, and then within our wire we will connect a resistor. So this time we will connect a resistor like this. Already you can see our circuit is complete, hence current is flowing. When you will see the values, you will see, but when you will measure the current in this case, so again it will be, because it's a direct current, you can see the graph over here. And let's drag the current meter here, or ammeter, and it is 0.90. V is equal to IR, simple. Now we'll add another wire here, okay, and another wire here, and then let's add this resistance, okay. So first resistance was, let's say, 2 ohms. So we'll adjust its value to 2 ohms. 2 ohms, okay. Second resistance, we can adjust it to 5 ohms. Yeah, yeah, 5 ohms. So the three examples that we are taking is 2 ohms, 3 ohms and 5 ohms. So one more resistance we can add here with the wire. This is how you can add it. And let's add a wire, and then finally a resistance. And in this case the resistance we can put as 2 ohm this and 3 ohms. So let's drag it 3 ohms. Okay, now we have the total resistance. Now as per our calculation from this website, we can see it is 0.97. Okay, so the total resistance the circuit for the circuit is 0.97. So let's write it down. So V is equal to IR, that we have learned from the Ohm's law, and total resistance is 0.97 ohm. Okay, and we have to remember one important line here. It is worth noting that in parallel circuit the total resistance is always less than the smallest individual resistance. So the smallest individual resistance is 2 ohm, and hence we are getting 0.97 ohm. And now, so we know the voltage, which is 9, so 9 volt, and we have to calculate the current, and resistance is 0.97. So now what we can do, we can divide 9 by 0.97, which will give us our current. And since we are doing this experiment, we can calculate it directly. Let's open Google. So here it is 9.27, and now let's go to our circuit and let's measure the current. 9.3, which is close to 9.27. So we will assume it's an approximate value, and here it is 4.8, and here it is 3. So here it will be 9.3, because at this particular end you will see the total resistance, right? Because at this end all three resistance will be in the circuit, and hence this particular formula will be applied, and hence the total resistance, which is 0.97, will be there in the circuit, and with that we are getting 9.37. So this is our simple explanation of how to connect elements in series, and in particular how to connect resistance in series and in parallel, and how to apply Ohm's law over it. You can try something like this on your own. Try to change different values and see if your calculations are coming right. Thanks for watching this video. See you in the next educational video of Odtutor. Follow us for more content like this.